All right, this will be the tutorial for LP360 version. I think it's what 24 to 55. Covering the entire workflow from importing the raw data. The sensor we're using will be the TrueView 540. It's the CHC Nav AA10 sensor. And we'll go over the entire workflow, including geocoding the data, classification, control points report, as well as creating our ortho. So to get started, you can see we have LP360 open. I'm just going to close the startup menu. And then we are going to select the sensor tab, cycle import. Make sure import flights in the new project is checked, TrueView microdrones. Next. And then from the imports wizard, we're going to start with our cycle folder. So click folder and then go find your raw cycle folder. Select that and then go ahead and hit select folder. Get that dude out of the way. Click next. Then you're going to go find your static observation file or your Rhinex file. And that punk's getting in the way again. Select that. Click next. Dude, you're starting to bother me. Get you out of the way. And then from our output selection, we're going to hit the ellipsis and then go find a place where you want to set up your project. And give it a name. What version is this? It's 24 to 55. And then you can see we've got everything ready to import. From this screen, we can also enter our control point. I actually already have it set right here. So I'm going to select that guy and click Finish to import. All right, at this page, you can see that we've got our trajectory points, trajectory line, and photos imported. I'm going to go ahead now and select or import our project border. So to do that, we're going to select Project, Add Files, Feature, and then go find my KML or my KMZ. Now, if you're using a KML or KMZ, make sure you select Transform Feature down here at the bottom and click OK. Now, since this is just a tutorial, I'm actually, and so we can process the data quicker, I'm going to actually change the size of my project border. So to do that, I'm going to select Feature Edit. Then over here under Active Feature Layer, I'm going to select my KML, then select Edit, and just make the adjustments necessary. Make sure you hit Save Edits, then yes. All right, next step, I'm going to go ahead and import my check shots. But before doing that, we need to make sure if we're using the 3D module that we have everything set up correctly. So here's the text file for my check shots, and you can see I've got the description, I've got my my y-axis, x, and elevation. Then I have a description along with this 0 here, and that will eventually be column number 6. when I import into LP360. And the reason why I have that is if you're using the accuracy star, which I am, you can see right down here at the bottom is my control point. You have to enter your height offset. So for the accuracy star, the height offset for when I had it set up over my control was 4.7655 feet. Now, if you're importing your control with the accuracy star along with your check shots for the project, you have to have an equal number of columns for your text file or CSV file. So that's why I've got this 0 in these other lines. Now, if you're going to use the automated tool in the control points report, they've got LP360 has specific codes that you'll use. So I've got FK, which means full check. If you're using the concentric target, I think it is CS. If you're using the checkerboard targets, it's CB. There's some other codes or other descriptions as well. Just go to the knowledge base and you can get the codes there. So we've got everything set up correctly in our text file. So I'm going to go to control points, import, add, and go find my text file. Then I am going to hit the ellipsis here to select a folder where the shape file will be created when we import our check shots. Then we're going to click next, select delimited, then next, then choose your delimiter, then next. Then here is where we will set up our columns. So column 1 will be name, 2 northing, 3 easting, 4 elevation, 5 will be type, and 6 will be my H offset. Finish and complete. We're going to go over here and I'm just going to make these a little easier to see. There they are. Okay, so the next step is we're going to go back to sensor and select trajectory processing. I'm going to click next. And then here is where you'll enter your control point. If you haven't already, you'll just hit the Survey Nail Manager, add, and then enter the details for your control point. Click next and submit. Okay, so our trajectory processing is processing in the background. We will view it here in our job manager shortly. But for now, we're going to go ahead and create our flight lines. Just click create flight lines. And then now I am going, if I need to make any changes over here, I can. What these settings are telling us is for the numbers that I've entered here, it will not create flight lines less than 100 feet within 10 feet of a radius and of a turn radius, or I'm sorry, within 10 feet of a turn, and the maximum deviation for the trajectory will be 20 feet. And if you just hover, it will actually give you a description. So for this, max deviation breaks a single line into 2 separate lines with a distance of a point greater than X from the current line center. So for example, let's say it's a windy day, the drone's flying along, strong gust of wind comes up and blows it off course a little bit. It will not process that depending on what deviation you have right here. You also have to keep that in mind if you are mapping rolling terrain. So just be mindful of that. So I'm going to go ahead and hit compute flight lines. We'll move this guy out of the way. And here we can see our flight lines. Now, since we're only processing the area within our boundary, we do not need to process everything else. So to do that, first thing I'm going to do is on our flight lines here, I'm going to click next, and here, I'm sorry. Yeah, I had that right. I'm going to click next, and we're going to go in here and edit our flight lines. But you have to do this process first. You can't immediately go in and manually create flight lines. If you've already used LP360, I know some users will use the manual flight line creation tool instead of the auto create. But with this version, you have to manually create them first because you're going to need to create that shapefile in LP360. So now what I can do is just go in and I am going to delete all my flight lines. We're going to turn our trajectory points on over here in the table of contents. And then now we can go in and manually create our flight lines. Select trajectory points. And then I'm going to click sensor. Feature edit and manual flight lines. There we go. So now I'm going to turn off my trajectory points. And clean everything up. Actually, I like using the lasso tool. And to delete these, I am just hitting the delete key on my keyboard. All right, all that looks pretty good. I'm going to hit close here. And we are all set. So to check our trajectory processing, we can go into the job manager. If I go to my sensor tab, all the way over here on the right-hand side is a job manager, and then up here at the top as well, right there. And here we can see it churning and burning right here in the background. Okay, you can see now that our trajectory processing has finished here in our, we're getting the alert that it has finished here in our job manager. So we're going to click that guy. And here it is up here at the top saying it's ready. So we're just going to highlight that, click complete job, and yes. Now we're going to run the post-processing. So before we run the post-processing, you can see that we do have a point cloud that has been created. And what we are looking at is the point cloud for basically the entire duration of the data acquisition from the time it began collecting the data to the time it ended. And if we go up here to our display type and go to point source, we'll see that we are not able to retrieve any of the point source information. That's because this data has not been geocoded. So extremely important. Do not stop at this step because this data, none of the points have the geocoded X, Y, and Z values. All right, so to complete the geocoding of the point cloud, we're going to click post-processing. And we can enter our clip angle right here, the maximum clip angle for the, or I'm sorry, the maximum scan angle for the TrueView 540 is 75 degrees. So that would be what, 37.25 degrees. You can just leave it at 40 and that will be fine. Clip range is the range from the sensor that you want to clip out. So these values right here, what that would mean is minimum 3 feet. That means it will not geocode any data that is within 3 feet of the drone. Maximum 75. That means it would not geocode any data beyond a 75-foot distance from the drone, and that is a radius. So right here, we can select the starting flight line number that we want to geocode. So for example, if I only wanted to do just one of these flight lines, I could do that. And to retrieve our flight line number, let me close that. I can right click on flight lines, go to feature analyst. And there's flight line 1, 2, 3, 4, 5, 6, and 7. So we are going to only retain photos within the flight lines. And we want to update our photo EXIF tags with the TruePose information. I'm going to run our post-processing, and it's now going to geocode our data based on our flight lines that we created. Okay, we can see here in the background that our point cloud has been geocoded. And our next step is we are going to go ahead and run our strip adjustment. Now, the strip adjustment, to just check to ensure that we need to run your strip adjustment, we can change our view type to point source. And I'm going to change this to points. And I'm just going to kind of zoom in on some of the overlap right here. And I can immediately see that we need to run our strip adjustment. I can also select our Drake profile by point source, and we can see that we definitely have some flight line separation going on. To run our strip adjustment, I am going to select strip align, and I'm now going to select the point cloud that we want to run this on. Right there. Give it a new name. This one called it adjusted. And hit submit strip align. Yes. Click OK, and we will get a notification here when the strip align tool has completed. All right, Job Manager is telling us the strip adjustment has concluded. So we can go up here and highlight the job and click complete job. Okay, it's telling us that the new strip adjusted layer has been added. Close that out. And we can see right here is our new strip adjusted layer. There it is. All right, so if we go and change it from points to 10 surface, and I'm going to go back to our, oh, that's not it. There it is. All right, I'm going to go back to our original point cloud. So we can see there is the original point cloud, and there is our adjusted point cloud. Okay, so the next step is we're going to go ahead and smooth out our point cloud. So I'm going to go into the table of contents. I'm going to select point cloud task here at the bottom, and we are going to select smooth point cloud. So feature geometry, I'm going to hit the ellipsis right here next to that. And the drop-down menu, we're going to select shape layer and select our project border. There's that guy. And our source points is going to be the active LAS layer, or I can just select it right there. Now I need to tell it what filter we want to run this on. Now we have not classified anything, so I am going to select, I can either do all points or created never classified. And then we need to set up our output location. So to do that, I am going to highlight that. And then up here in the top right-hand corner, we'll select our project path. And it's going to take me straight to the project folder. And we already have a LAS folder right there. I'm going to right click, create a new folder, and call it smooth all points. Close that guy out. Now that I have the 3 green check marks over here, it lets me know that we have our inputs and outputs set up correctly. Close that. I'm going to click apply and go up to point task and by active layer. Click yes. All right, we can see that the point cloud task has completed. And if we go back to our table of contents, look up here at the top, we can see that we have our new LAS layer. We're going to go ahead and change the name of that. And we're going to select that as our active LAS layer. The next step in the LP360 workflow is to run our control points report. So to do that, we are going to select the control points menu, then select accuracy estimation, go to settings, input points filter. I'm just going to double check, make sure that nothing's been classified by clicking the refresh button. As we can see, nothing has. So we can just leave that as is, or if you want, you can select created never classified or all points. Click OK. The method is going to be the inverse distance weighted method. And we can leave the fixed radius at 1 foot. So then select OK. And our quick set is going to be concentric target. Then click auto find. All right, so we can see that we do have a little bit of an offset here. Looks like about just a little under 1 inch on the x-axis, a little over 1/10 on the y, and our vertical is right at 100. So to make those corrections, we are just going to click solve. And we can see the corrections that are going to be made right here. Then click apply correction. Okay, once the control points report has finished making the corrections, you will see that there has been a new LAS layer created. So we're going to select that new LAS layer 1. Then we're going to go back to our control points report by clicking control points, then accuracy estimation. Going to select the concentric target and auto find. So if we come down here to the bottom, we can see that we now have the corrections made. Our x-axis is now 8 thousandths. Our RMSE is 12 thousandths, and the vertical is 0. If you are using the accuracy star, the workflow is going to be very similar. Again, in the control points menu, we're going to select accuracy estimation. We're going to check our settings, input points filter. See all points have been selected. If I click refresh, I can see that nothing has been classified. I'm going to click OK. And we're going to select inverse distance weighted method. I'm going to leave my fixed radius at 1 foot, then click OK. In the drop-down menu here under quick set, I'm going to select accuracy star. You see that we've got the correct type set up right there, AS. And then now we're just going to select auto find. All right, we can see that it has completed. We go to right down here at the bottom. See right here where it was able to pick up our accuracy star. And we can see down here on our X, Y, and Z axis, there are a few adjustments that needs to be made. Not much, but there are a few. So we're just going to simply click solve and apply correction. Now that we can see that the task has completed, here is our new LAS layer 1. Again, I'm going to go back to the control points menu, accuracy estimation. I'm going to select our accuracy star and auto find. All right, it now has completed, and we can see that we still have our accuracy star selected and everything has been zeroed out. So we now can rest assured that we've got this entire point cloud tied in as accurately as possible to our control point. So the next thing we're going to do is we're just going to go to our drop-down menu. We're just going to select all and auto find. Okay, the control points report has finished running, and we can see here are our numbers at the bottom, our RMSE, planimetric, and the new ASPRS class of 3 dimension. We're going to turn off the control, and our final, let's see, our final X is just under an inch, final Y is about a half inch, and our vertical is right around a quarter of an inch. Now, these are using the new ASPRS accuracy standards. And what is really important to pay close attention to is our RMSE in relation to our standard deviation. So we can see that here for our x-axis, our deviation is 200ths compared to 700ths for our error. For our y-axis, our deviation is just under 200ths with just right over half inch for our y-axis. And then if we look at our vertical, we can see that our vertical is about a quarter of an inch with a deviation of about 5 thousandths. So that tells us that we've got a very equal distribution of error throughout the data set where our check shots are located. Okay, we're ready to go ahead and classify our point cloud. So I'm going to go to point cloud task, and in the drop-down menu, we are going to select ground thinning. So as with the previous point cloud task, we're just going to start from the top, work our way to the bottom. I want to run this on the entire project, so we're just going to leave tool geometry right there. We want to run this on the active LAS layer, which is our smooth point cloud. And for our input points, we want to select created never classified. Now I am going to change this from feet to meters. And I'm going to run this on a 1 square meter cell size. And my settings, I am going to thin this from, I have no idea how many points are in this point cloud. Let's take a look here. Yeah, almost 95 million points. And we are going to thin it down to 8 points per square meter. So to get a good sample size for each cell, I'm going to select the lowest point, the highest point, 1 median point, and then 5 random points for a total of 8 points per square meter. Now the destination class for this point cloud task is going to be ignored ground. Select OK, apply, go up to point cloud task, and we are going to execute by active layer. Okay, so if we go to our filter right here, and if I go down to my temporary ground, I'm just going to zoom into a small area here. And if we force 100%, I'm now going to draw my profile window. We'll just kind of get an idea of how things look here. All right, so here is the thinned point cloud. That off. And if we go back to all points and kind of get an idea of our progression. All points, and then here is our temporary ground. Okay. So my next step is to find a way to close this profile window. There you are. And we're going to now begin running our iterations. So to do that, I am going to select ground classification, perform iterations. And this time my input filter is going to be my temporary ground or ignored ground right there. I hit the refresh, and then hit scan. Yep, there we go. We already went from 95 million to 412,000. So we're only going to be creating our ground from those points. And my destination is going to be ground. I'm going to have key point set. And here is where we are going to set up our seed sample distance. We want to generate seed points. And we are going to start with a 20-foot seed sample distance. My angular threshold, I am going to start with 1.75 feet with a maximum distance of a half foot. I'm going to have, let's see, omit edge climbing algorithm, and we're going to perform 25 iterations. Apply and execute. All right, we see that process is done. Go up to my ground filter. And let's force 100%. And see how this looks. That turned out pretty good. We can see that we've got some areas that we are going to need to clean up for our ground. I can tell just by looking at some of these areas. So the best way to do this is we are going to turn off my background map, and we are going to go from 10 to points. I can see just some areas around here that we need to clean up. Now, to do that, I am just going to run the same point cloud tasks that we did earlier, but I'm going to just adjust my seed sample distance from 20. I'm going to go down to about 15. And we're going to leave the angular threshold. Yep, we're going to leave the angular threshold there for now. So I'm going to click apply. And I'm going to use by polygon up here. And I'm just going to draw a polygon around these areas that we need to adjust. Or we can use, actually, we can use any of these. We can use by envelope. We can use by circle stamp. A rectangle stamp. I would not do active layer or by feature layer because I do not want to run this on the entire project. So you may need to make some adjustments to the angular threshold as well, depending on how steep some of these the terrain is. And that's what we are going to do right now. So we're going to bump that up to 2 degrees. And we're going to try this again. Okay, so once you get finished cleaning up your point cloud, there's a bridge over here, big ridge right here, and a lot of rocks and things over here. The next step is we are ready to go ahead and export our surface and create our contours. We can also use this step to double check to make sure that we got out all of our vegetation and false ground points as well. So what we are going to do is we're going to go up to where is it? Back to our project tab, export wizard, and we are going to export our contours. Now our import points filter is going to be our ground. And cell edge length is going to be 1/10. I'm going to select contours. Cookie cut by polygon. There is our project border. We select name for name field, click next. And then here at the ellipsis, we are going to set up our export location. So I'm going to create a new folder, call it contours. Click OK and finish. All right, we can now see our contours. Not really seeing anything that is jumping out at me. And there's a lot of jagged rocks and things over here, so that is about to be expected. And from here, we can go ahead and export our surface. Just go to Export Land XML. Our filter is going to be our ground points. And what is the total number of points we have here? 135, 896. So here's where you would enter the maximum number of points. And now set up your output location. You see, now we have our land XML right there. And if you're like me, you have a lot of customers who like the really nice cartographic contours. What you can do is you can go in and smooth your ground points again. So we'll go over to Smooth Point Cloud. And we're going to select our active LAS layer, which are smooth all points. Select our ground points. Select our output location. I can't do that. I have to set up our project path. I have to do that. There we go. This time I'm only going to output our ground points. So I'm going to select smooth, output only smooth points. Apply, and we will execute our point cloud. So here we can see over here on the left is our active LAS layer. I'm just going to rename that guy real quick. And we want to recreate our contours. We're just going to go back to our export wizard and run the same export wizard as we did previously with our contours, and it will still have the same settings in the export wizard for us. Okay, and finish. Oh, I believe I might have forgotten to select 1 foot contours. Yep. There we go. Now, the final step is if you actually need to create a grid, we can go into our export wizard, and this time we're going to select elevation. You will enter your grid size right there. So if you want a 1 foot grid, 2 foot grid, whatever it is, there's a 3 foot grid right here. Select GeoTIFF. Set up our export location. And finish. And then now when we, the final step to create our grid is we're going to go back to our import wizard, add files, and we're going to select DEM to LAS. We'll go find that DEM we just created. Okay. And there's our 1 foot grid. I think it's a 3 foot grid. There we go. Okay, that is the standard workflow for LP360 version 24.255.